Hello, Math 157ers. This is Professor D with a recording on hypothesis testing. So what I am using is a version of PowerPoint slides from the introductory statistics book, but these are things that I have modified for my own use. Okay, so why do we use hypothesis testing? Well, you could use a hypothesis test to decide if a dog breeder's claim that every Dalmatian has 35 spots is statistically sound. So when you do hypothesis testing, you have a null and an alternative hypothesis. Here, the null hypothesis would be something along the lines of all Dalmatians have 35 spots. And you could test the alternative as them having more, which would be less than, or maybe greater than, or even just they don't have 35 spots. So what is an hypothesis test? The first thing you need to do is convert the research question to a null and an alternative. The null hypothesis is a claim of no difference in the population. While the alternative hypothesis, you're claiming that the null, sometimes called H naught, H sub 0, sometimes people call it H naught, and the alternative H sub A. But the alternative hypothesis is trying to claim that the null hypothesis is false. So what we would do is we would collect data and seek evidence against H naught as a way of bolstering HA. So before we even talk about the different types, you could say a null hypothesis might be that the mean age of TCC students is 25.4 years. So what you would do is you go out and collect data, and based on that data, you could test your null hypothesis. Now you have to make sure you get a big enough data sample size and all those other types of things, but that's just sort of a basic setup. And you might think that the alternative should be that the mean age is less than that. So H naught, right up in here, is that the mean is greater than some number, and the alternative is that the mean is less than some number. Okay? Greater than or equal to, less than or equal to. So that makes it a left-tailed test. And when you look down here, what does a left-tailed test mean? That we're looking actually at this area pointing to the left. See the arrow pointing to the left? That makes it a left-tailed test. Sometimes you can write a null hypothesis is H naught is equal to some mean, and the alternative would be less than some mean. Okay, HA, H1, HA and H1 are interchangeable. That just means the alternative. And I did not mean to go there. In a right-tailed test, you're basically testing that you think the alternative is bigger. So with the age concept, the mean is, you might say that I think I said 25.4 years. So that H naught is the mean is less than or equal to 25.4, and the alternative would be that it would be greater than. And if you looked at it, the we're computing p-values again. We did p-value calculations back when we just used the normal distribution. You're looking at this side of the curve. Now sometimes you want to do something called a two-tailed test, and that's just where you think it's actually just not equal to the claim. Again, because it's two-tailed, we're using area and two sides of the curve. With hypothesis testing, you can use Z and you can use T. But just like with confidence intervals, when dealing with the mean, we are specifically using T. Because when you use Z, your sample size has to be significantly large or the population standard deviation is known. Now, if you're doing a confidence interval, the population standard deviation is known, you also have to know the population mean. So confidence interval doesn't make a lot of sense. Same concept here. We are going to use the t-statistic because we're going to be using a sample standard deviation. The other thing to keep in mind too is that when when the n becomes significantly large enough, when the number of samples you have becomes super large, then your t and your z numbers, they're almost the same. Okay? So, critical value of t, there are a couple of websites in here that have some nice things for you. This gives you as an easy calculator for the critical value of t. You also have a hard copy of this. So that's a nice thing to use if you have to find something. Let's go back to our slideshow. This one is also a t-table. The other one's t-table. Steps in hypothesis testing. I would recommend spending some time reading through here. Basically, this is taking you through all the steps. All right. You would state the null and alternative, collect and summarize the data, so you can calculate a test statistic. Step 3, we use that test statistic to find the p-value. And the way I have set it up is that you don't need to know the test statistic to find the p-value. You're just going to need to know the mean and the standard deviation. Okay. Now, easiest way to determine what to make of it is seen down here a little bit. And common decision rules. Okay, if the p-value is less than 0.05, often scientists will declare their data to be significant. Okay, what does that mean? It means that the p-value is the probability that you would get these results if the null value were true. So if you have a very tiny p-value of like 0.03, okay, the probability of getting that same type of result if the null were true is so small, it's like 3%, that what we usually say is when our p-value is less than 0.05, we reject the null hypothesis. And when it is greater than 0.05, we fail to reject. Now I want you guys to, after this, to come back in and spend some time reading this. It'll be very helpful to clarify any questions. And then the other one is just some more information on null and alternative hypotheses that you can take a look at after you finish watching. Alright, so let's do some examples. College Bookstores tells prospective students that the average cost of its textbooks is $52 with a standard deviation of $4.50. A group of smart statistics students thinks that the average cost is higher. In order to test the bookstore's claim against their alternative, the students will select a random sample size of 100, assume the mean from the random sample is 52.8 with a standard deviation of 4.5. Perform a hypothesis test at the 5% level of significance. So I'm going to try and do is a little bit of writing. So badly written, I know. Alright, so H naught, and that's a bad mu, would be that mu is equal to 52. And they think it's actually bigger, right? So you could write that as less than or equal to, or just as an equal to. And we would write our HA as mu, again badly written, is this really is to be greater than or equal to 52. And see how we use the same mean in both? That's very important because we are testing what is previously accepted. we are not testing the alternative. So the mu written in both questions has to be the same. Now, because our focus in this course is hypothesis testing and understanding using technology, we are going to pop over and look at the spreadsheet that I have made available for you. Please excuse my rustling. I was looking for a pen. All right, so I'm going to tab over. So remember, our cost of textbooks is $52 with a standard deviation of 450. And this is in Excel. Actually wanted to use it. This is it in here. All right, using T, because our population standard deviation is unknown. So it's they think it is greater, so that's going to make it a right-tailed test. So the first thing I'm going to do is I'm going to put in 52 here. And what that does is it comes over here and says, okay, it fills in my null for me. Mu is equal to 52, or mu is less than or equal to 52. And my alternative is that mu is going to be greater than 52. So remember, only fill in the yellow areas on this spreadsheet. So our sample mean was 52.8. And now I have to step back over because I don't remember our sample standard deviation. Our sample standard deviation is 4.5 and n is 100. Sample size was 100. Okay, so here's our t statistic calculated for us, 1.7778, and our p-value is 0.0393. So at the 5% level of significance, we would reject the null hypothesis, okay, because our p-value is significantly small, 0.0393. Now again, I said that we were going to stick with using T, even though these spreadsheets have the ability to use N here, we're going to stick with T. But I'm going to show you something. If we did, because our sample size was pretty large, it was 100, if I put my mean here, my sample mean, look at that. Look at what my Z, look what my numbers were. My Z was 1.778 and my P was 0.0377. So when our sample sizes get to be significantly large, we are going to see the same results. Now if we played with this a little bit and we put in a sample size of, let's say, 25 here, not 5, but 25, we have a p-value of 0.1914. And put 25 in here, and we see that our p-values are different. This one's 0.1870 and 0.19. But as those p-values, as those n's, as your number of data points get to be significantly large, then you're going to get very similar results with the two. So our decision is we would reject the null hypothesis, and now we did not prove that the cost of textbooks was $52.80, but we would reject the null hypothesis and basically say that there is significant data to suggest that the true cost of textbooks is greater than $52. Okay. And guys, here's another one. Certain chemical pollutant in the Genesee River has been constant for several years with a mean of equal to 34 parts per million. A group of factory representatives whose companies discharge liquids into the river is now claiming that they have lowered the average with improving filtration devices. A group of environmentalists will test to see if this is true at the 4% level of significance. They have a sample size of 50, a mean of 32.5, and a standard deviation of 8. So let's perform our hypothesis test. So again, Mu is really our H naught is that mu is greater than or equal to 34. I hope you guys can't hear my kids screaming. And HA is that mu is less than 34. So we need to put our numbers in.
Hey, what are you doing?
Hopefully that'll help. Alright, so it's going to be less than. Which type of test? It looks like it's going to be a left tail test because it's less than. 34, I said 32.5, our sample standard deviation was 8, and we're looking at a sample size of 50. Alright, so there's our t-statistic, and our p-value is 0.0955. Well, 32.5, that looks better than 4, but you have that sample standard deviation of 8. And our t-statistic was negative 1.3258. And our area, our p-value, is 0.0955. Well, there's a problem. I don't think we can reject the null, because if you think about it, here's your curve. I know it's awesomely written, but here is that area, and it was 0.0995. So 4%, 0.04, is not 0.0955, is actually greater than, put the 0 in, right? So the problem is we really needed a p-value less than 0.04, and 0.0995 is, much bigger than 0.04. So in this case, we would fail to reject the null hypothesis and say that the sample data does not support the claim, the alternative claim, that this group of these filtration devices has lowered the amount of pollutants in the river. Okay, I'm going to skip this one. This is a two-tailed test, but again, we would go over to the two-tailed. Nu is equal to 0.5, N is 25, so 0.51, 0.04. So here we go. I think it was 0.5. I already forgot. 5% level significance, 25, 0.51, 0.04. So that's a pretty large p-value. Our p-value is 0.2234. That would indicate, since our p-value of 0.2234 is greater than 0.05, that we would fail to reject the null hypothesis, and we would say that the data does not support the claim that the diameters of the ball bearings are not equal to 0.5 centimeters. Okay. There are things called type 1 and type 2 errors. If you do not reject H naught, so basically if you fail to reject H naught is really and H naught is true, you've made the correct decision. But if you don't reject it and H naught is not true, it's called a type 2 error. The same thing here, when H naught is true and you reject it, it's called a type 1 error. And then when H1 is true and you reject the null, that's the correct decision. So these are two good resources, and I would want you to go back in and watch these two recordings on the types of errors. Okay. Again, this is just some pictures of p-values, left-tailed. Here, p-value is 0.0187, so it's going to show up its corresponding test statistic was negative 2.05. When alpha is 0.05, anything from 0.05 to the left is considered the rejection region for H0, and this is the rejection region. Your TI calculators will also do hypothesis testing. If you want to do it by a list, you would put it in. You put your data into a list. So when you're putting raw data in, you put data. You have to put your mu naught in to list frequency, which one. If you were going to use stats, or if you were given stuff, you choose the stats option, and it would ask you for your mu naught, your mean of your other, and your sample size, and then you would choose which one to use, and it will actually show you a picture. Proportions work very much the same way. You can see left-tailed test, right-tailed test, and a two-tailed test. Again, left tail, this arrow is pointing to the left, right tail, the arrow is pointing to the right, not equal to, it's both. We use a z-test statistic for proportions. So you have p hat minus p naught. You've seen parts of this before when we worked in confidence intervals. When you get to doing proportions, there is another spreadsheet, and it's the same idea. You have your left-tailed, your right-tailed, your two-tailed. You put in your proportion. You'll put in your x, the number of x that fulfill the correct thing, and you put in your sample size, and the rest of the stuff is calculated for you. This is actually confidence intervals, so I need to fix that. No, that's right. You can still get your standard error. I'm looking at the wrong sheet. So it'll calculate your p hat for you, your standard error, your test statistic z, and then your p-value. And again, if your depending on your if you're testing at the 0.05 level, your p-value has to be less than 0.05. One important thing to note when you get to the proportion section, let's say it gives you a percentage and a number, but doesn't tell you the x. Well, if it tells me that 75% of the voters voted for candidate A, and let's say it was 300 voters, okay, well we should be able to find what our x is, because our x is 0.75% of 300, so 0.75 times 300 would give me my x. So here my x would end up being 225 over 300, and my p hat value is 0.75. And I know that comes up sometimes, so I just wanted to throw that in there. So that's what I have for you. You also had some other readings that I want you to do, but hopefully this will give you a jump start on this. Take care.